Look up at the night sky. For millennia, humans have gazed at the stars, filled with wonder. We see predictable patterns, the steady glow of planets, the familiar constellations. But the universe is not static. It is a dynamic place of immense energy, constant change, and sometimes cataclysmic events. Among the most dramatic of these are supernova, the explosive deaths of massive stars. These explosions are more than just beautiful light shows. They are fundamental to the cosmos and, ultimately, to our own existence. This article explores some stars that might soon offer us a front-row seat to such an event. But more importantly, it invites us to think critically about what these cosmic fireworks truly mean, and what they teach us about the universe and our place within it. What is a supernova? The cosmic forge. Simply put, a supernova occurs when a star significantly more massive than our sun runs out of fuel. Its core collapses under its own immense gravity, triggering a rebound explosion of unimaginable power. For a brief period, weeks or months, the supernova can outshine its entire host galaxy. But the significance goes deeper. The intense heat and pressure in these explosions forge heavy elements. Elements like gold, silver, iron, the very building blocks of planets, including Earth, and life itself. Supernova are cosmic recycling plants, scattering these vital ingredients across space, seeding the next generation of stars and planets. Understanding them helps us understand our own origins. Candidate 1. T. Coronae Borealis. The recurring visitor, our first candidate, T. Coronae Borealis, TCRB, located about 3,000 light-years away, offers a fascinating twist. It's not set for a supernova, but a nova. This distinction is crucial for critical understanding. TCRB is a binary system, a dense white dwarf star orbiting a red giant. The white dwarf pulls material from its larger companion. When enough material accumulates on the white dwarf's surface, it triggers a runaway thermonuclear explosion. A nova. What makes TCRB special is that it's a recurrent nova, exploding roughly every 80 years. The last confirmed event was in 1946. Astronomers predict, based on its recent behavior, like a significant dimming period followed by recovery, similar to pre-1946 patterns, that it could erupt again very soon, perhaps sometime from 2025 onwards. When it does, it will dramatically brighten from being invisible to the naked eye to potentially matching the brightness of Polaris, the North Star. It will appear as a new star for a few days or weeks. Thinking deeper. What does a recurrent nova tell us? It highlights the dynamic interactions within binary star systems. It shows that stellar explosions aren't always final acts. Observing TCRB's cycle allows us to test and refine our models of accretion physics and thermonuclear flashes on white dwarfs, processes common throughout the universe. Candidate 2. Betelgeuse. The familiar red giant, Betelgeuse, the prominent red shoulder star in the constellation Orion, is a true supernova candidate. This red supergiant, about 10 to 20 times the mass of our sun and roughly 640 light-years away, is nearing the end of its life. It will explode as a Type 2 supernova. The question isn't if, but when. When could be tomorrow, or it could be 100,000 years from now. This vast uncertainty is a lesson in cosmic timescales which dwarf human experience. In late 2019 and early 2020, Betelgeuse dimmed dramatically, sparking intense speculation. Was this the prelude to the main event? Further study suggested the dimming was likely caused by a cloud of dust ejected by the star itself. If Betelgeuse does explode, the sight would be unparalleled. It would become incredibly bright, easily visible during the day, possibly rivaling the full moon's brightness for weeks or months before fading. It poses no danger to Earth due to its distance. Thinking deeper, Betelgeuse prompts us to consider predictability in astrophysics. The Great Dimming Event, while not the explosion itself, provided invaluable data on the mass loss processes occurring in stars before they go supernova. It was a real-time test of our theories, forcing scientists to refine models. How do we interpret stellar behavior when the final outcome is certain, but the timing is profoundly uncertain? Candidate 3. WR124. A violent farewell. About 15,000 light-years away lies WR124, a Wolf-Rayet star. These are very massive stars in a late, unstable evolutionary stage. They are characterized by powerful stellar winds that strip away their outer layers at tremendous speeds, enriching the surrounding space with heavy elements even before they explode. WR124, about 30 times the Sun's mass, is shedding material furiously, creating the beautiful nebula M1267 around it, vividly captured by the James Webb Space Telescope. WR124 is expected to detonate as a Type IB or IC supernova, collapse of a massive star that has already lost its outer hydrogen envelope. This could happen within the next few thousand years, or perhaps sooner. The explosion would be visible from Earth. Thinking deeper, Wolf-Rayet stars like WR124 represent the final turbulent stages of the universe's most massive stars. Studying them, and the intricate nebulae they create before exploding, gives us direct insight into the complex process of stellar evolution and element dispersal. How does the pre-supernova mass loss influence the eventual explosion and the remnants left behind? Like a neutron star or black hole. Coronae Borealis, Betelgeuse WR124. These are just a few cosmic neighbors poised for dramatic transformation. Watching them, whether it's the recurring flash of a nova or the potential cataclysm of a supernova, connects us directly to the grand cycles of the universe. These events challenge us to think critically. They remind us that the universe is constantly evolving. They force us to grapple with immense timescales and distances. They show science as a process, observing, predicting, refining theories based on new evidence. The anticipation is exciting, but the real value lies in expanding our knowledge, understanding the processes that created the elements within us, and appreciating the intricate, powerful, and ever-changing cosmos we inhabit. So, keep looking up, but more importantly, keep asking why.